and we are starting with translations. Translations and transformations sound very similar, but a translation is a type of transformation. So our lesson today is from 2.1. Our essential question, how do you draw the image of a figure under a translation? And then we have 3 I can statements. So these are the 3 things that we're going to be able to do, hopefully, by the time we're done with this lesson. I can draw the image of a translation, given a pre-image and the description of the transformation. I can create the image of a figure, given a rule and the pre-image. I can generate a rule and coordinate notation that describes the transformation of a pre-image to its image. All right, so these are the things we're going to be learning about today. Translation is moving. Yes, it is. Transformation is a physical change. Sure. Yes, that works.
If you will technically a physical change to what's on the plane.
Yes, we're talking about in the plane. Absolutely. So you guys, in 8th grade, this was something that you had a unit in and when you were in 8th grade. And I'm not really sure if algebra touches on it very much, but we touch on it again in geometry, okay? And now we look at it just a little bit more in depth. So like with translations, we can actually describe them with vectors, okay? And so some vocabulary that's important for this lesson is a vector, which is a quantity that has both direction and magnitude. And that is a picture of a vector there, going from point E up to point F. It has direction because there's an arrow on one side, and it has magnitude. It has a length, all right? And so you can represent a vector with the 2 endpoints and this symbol on top, or the name of the vector itself, which could be the entire thing as a single letter with a little vector symbol on top. And so the 2 points, you have the initial point is where it starts, and the terminal point is where it ends. So in this picture, E is the initial point, F is the terminal point. Transformation. So the whole unit is about transformations. It's a change in the position, size, or shape of a figure. A transformation maps the pre-image to the image. And so the type of transformation we're talking about today are translations, which is a transformation where all the points of a figure move the same distance in the same direction. The figure is moved along a vector so that all of the segments joining a point and its image are congruent and parallel. And so here are some images of some translations. And one thing that I use to help myself remember and students remember when we're talking about translation, like what is a translation? So you can see in red font, I've typed out a translation is a slide. And notice that I've highlighted SL in both words. So because translation and transformation are so similar, the SL stands out. And then think of the word slide. Slide. Okay, and that means you're sliding. And so you can see that in this picture right over here with the yellow triangles. You have a pre-image, which is what you start with, and then it slides to the image, which is what you end with. And notice that the vertices, their names, A, B, C, after you slide it, after you translate it, it becomes A prime, B prime, C prime. Okay, so we still have our same vertices, but they've been translated and now they're slightly different. So then they come with a little like tick mark to show that they're different, but they originated from the original A, B, and C. And then the other 2 pictures, these are different translations. So you can translate to the left, you can translate to the right, you can translate up, you can translate down. You can do a combination of going to the right and up, like in this picture with the pink and the purple triangle. It's going to the right 2 units and then going up 4 units. So it's 2 movements in one translation. And then the last image on the right with the 2 triangles with the red arrows, the lighter yellow triangles. Well, that's just a single movement of 6 units to the right. Every point, every vertice of your plane figure is moving 6 units to the right exactly. All right, and so in this unit, we're going to be looking at coordinate notation. So if we have the coordinates of a plane figure, those vertices that represent the coordinates, those coordinates that represent the vertices, I said that backwards, then we can represent what's happening to them, not only visually like in the last slide, but through notation, mathematical notation like we have on this slide. And if you look at those, they're not parentheses, they are very jagged. They kind of look like overextended, greater than or lesser than signs. And so that is vector notation. And so these are the rules for translation on a coordinate plane. If you were translating a single point, a point x comma y, or yes, a point x comma y, and you move that point to the right, well, you're actually changing the x coordinate because you're moving to the right. And so the way that gets represented is you're adding that much to the x. If you translate a point a units to the left, well, you are subtracting a units from the x coordinate. So left to right, we're talking about changing the x coordinate. Whereas when we go up and down, we're talking about changing the y coordinate. So when we move up, our y coordinate is increasing. We go b units up, it increases by b, we add b. But if we move down, b units down, then we are subtracting b from the y coordinate. Okay, at this point, I'm going to turn this into student paste, which means you can now go through any of the slides. And I want you to go through all of the slides. There are videos to watch, there are examples to look at, and there's lots of interactive slides. I want you to go through and try all the different slides. We're going to come back and go over what you guys did at 10:40. Okay, so I share this instead. Student pace mode until 10:40. Because I think in order to see what I'm presenting, you have to be in the Google Meet, but I could be wrong. We'll find out. Okay, so for this interactive slide, draw a translation. It says plot the image of point P under a translation by 5 units to the right and 7 units down. Let's see if this first one is correct. 1, 2, 3, 4, 5 units to the right. 1, 2, 3, 4, 5, 6, 7 units down. Perfect. Okay, so you should have a point at 4, 2. So this one's a little too high, but I like how you put P prime. That was nice. 4, 2. Nope. Yeah, okay. 4, 2 is right where you want your point to be. So some of you are a little bit off. 4, 2, this one's correct. All right. And if you wanted to label it, it would be P prime. That is absolutely correct. Okay. So that's how we do that one. And then this next part was generate a translation rule. So we're going to determine the translation that maps the pre-image. Okay, the pre-image is this blue polygon, FGHI. What do we do so that it turns into F prime, G prime, H prime, I prime? What is the rule? Okay, so as you're doing this, a method would be to look at these individual points, and they're all going to follow the same rule. So you could take like G and get to G prime. What do you have to do? Looks like you have to go to the right a certain number of units, so that's a positive movement, and then you have to go down a certain number of spaces, which is a negative movement. So let's see what we came up with. Awesome, 13 of you got it correct. Proud of you guys. Okay, that is correct. So if we go 6 to the right and 3 down, I'm sorry, what?
I said nobody got it wrong.
Nobody did. That's really good. The next part is to take it to the next step and write that rule in coordinate notation. Okay, 6 to the right, 3 down. What does that look like? Awesome. 6, -3 is absolutely correct. A positive number means you're moving to the right in the x coordinate location, And a negative number in the y-coordinate location means you're moving down. So 6, -3. 6, -3. 6, -3. 6, -3. Okay, so make sure that your 3 is negative, and then that would be correct. And then determine the rule. So this is an example. You had a video, and then you have an example here where you have some coordinates of your pre-image, ABC, and the vector that we're performing is 4, 6. So we're going 4 to the right, 6 up, and we're changing every ordered pair by adding 4 to the x, adding 6 to the y, and then plotting the answer. So over here, let's see what you guys came up with. -2, 3. So let me show you the correct answer over here. And then, okay. So what I'm presenting to you right now, this is the correct answer that you should have for that one. And I know it's a little bit confusing because the x coordinate of the vector -2, that means I'm going to subtract 2 from all the x's, but in that dark gray box, it has x minus already. So it's understandable if you made the real easy mistake of putting -2 in the box, but you should actually have +2 in the box because you already have the minus sign next to the x. And then the y coordinate of our vector, +3, means we're adding 3. So a 3 would go in the box. You should have +2 and +3 in the dark gray box. And then doing that to each of your ordered pairs, you should get 1, 3, 0, 1, and 2, 1. So if you were to plot all 3 points and connect them, you get a triangle. So the pre-image is triangle ABC, and the image after the translation is triangle A prime, B prime, C prime. So I'm going to use, I'm kind of going through your responses right now. And I know this one was more challenging. See if I could find someone who got it right. 2, 3. This person looks like they got it correct. They just did not get to the graphing part. Okay. So, I mean, this is something we're working on, all right? But, you know, it's our first lesson of this. So you don't have to be stressed out if you haven't got to that yet. All right, so what I'm going to do for you now is I am going to turn on student paste again. And